Okay, let's finish off 20 part B, the one where we have two standing waves, or two waves being created with a wavelength of 20 centimeters. And we want to know, well, how far apart are the nodes? So if we have two waves, and they're both 20 centimeters in wavelength, so let's just draw what one of those would look like, where this would be 20 centimeters. If they're going to create a standing wave, then that means the rope needs to be similar, or at least if it is a lot larger, then these waves need to be able to freely travel up and down the rope here, and when they cross they will cancel each other out and then or contribute to each other, and then when they pass they will be looking something like this. So if we have two waves, or if we have a wave anyway, and it is a wavelength of 20 centimeters and it stands still like this as it moves up and down, then the nodes will be these points here, where the wave is not moving. Obviously the rest of the string will move eventually as it travels along it. If, however, it doesn't travel along it, and that is the length of the wave itself, and then we have the other wave coming the other way, what we're going to end up again, we're still going to have these three nodes, and then these points here will move up and down, while these points here will not move. So if a wavelength equals 20 centimeters, the node distance is 10 centimeters. Okay, so it doesn't matter whether or not the waves are moving, or if the waves are just going up and down on a 20 centimeter long piece of rope here, or if the rope is considerably longer, the node distance, the distance between the points that aren't moving on the wave itself, will still be 10 centimeters. And yes, I do know that if we draw this wave, say a little bit of time later, that it's going to move, but these are still the node points and they are still 10 centimeters apart. That's why I think it's more this sort of scenario, and so these points actually wouldn't move at all. Alright, I hope that clarifies that. Thanks very much.